Good morning, sir. So, would we start? Are you ready, sir?
Yes, sir, ready.
Okay, Orpita, please start your Orpita and
Okay.
Subhasri.
Okay, sir. A very good morning, one and all. Respected dignitaries, invited guests, teachers, resource persons, industrial persons, and my fellow friends. On behalf of Department of CSA, CET Bhubaneswar, I, Arpita, and my friend Subhashi, your host for the FDP, welcome you all again, and we hope you all are doing good. So we have stepped into the third day of AICTE Training and Learning Academy's online faculty development program. And as we all know, this year's topic is artificial intelligence and machine learning.
Today we are having three technical sessions basically. Two of them will cover in the first half, and the topic machine learning in IoT and machine learning load balancing for web streaming and service application. The third talk we will cover after the lunch break is on the topic hands-on lab training for artificial intelligence using machine learning. So this was the overview of today's program. Now with all our good wishes and positive thoughts, let's begin our technical part.
Okay, thank you, Subhashi. So we are moving towards our first session. Let me have the privilege to introduce to you our first speaker of the day, Professor Rashmi Ranjan Rout, who is shortly going to give a demonstration on the topic machine learning in IoT. Speaking about him, he is currently working as an associate professor in Department of Computer Science and Engineering at National Institute of Technology, Warangal. He holds a PhD from Indian Institute of Technology, Kharagpur. He has specialization in fields like wireless ad hoc, sensor networks, Internet of Things, online social networks, mobile computing, distributed and cloud computing, and many more. We are really fortunate enough to have such a dynamic personality with us today. So, without any delay, I'll request Professor Rao to take the charge and begin the session. Over to you, sir.
Good morning to all the participants. Am I audible?
Yes, sir. Yes, sir, you're audible.
So can you see my screen?
Yes, sir, it's visible.
Yes, sir.
Slides are visible, right?
हाँ सर, yes sir. Please start.
Okay, right. So good morning to all the participants and the faculty members, research scholars, and all other dignitaries from CET and other colleges. So in this session, we'll be discussing what are the major IoT applications and what are the different challenges in IoT applications, and along with that, how machine learning helps uh, in IoT applications or making these IoT applications smarter and smarter. Right. So my slides are visible, right?
Yes sir.
Okay, right. Thank you. So we'll discuss some of the key points, smart sensor-based solutions, how we are generating data from sensors, and how this IoT is different than a traditional network, and where we are using sensors to generate data, or a device uses sensor to generate data, and what are the different type of sensing based solutions for IoT applications, key technologies, emerging applications. So in IoT, so what are the other methodologies? That means uh, what type of technologies we are using, what type of whether we are using machine learning to analyze data or generate different type of patterns for IoT and all, right? And similarly, mostly we'll also discuss a different type of machine learning approaches, or which type of application, or which type of application, or which type of machine learning approach will be suitable for IoT applications, whether all of them or some of them. Uh, so we'll be discussing. So smart city applications, along with that also we'll see that what type of IoT applications will be oriented towards or to solve how IoT will solve uh, different problems for smart city, right? So, and along with that also we'll see that how this IoT cloud communication happens, how this IoT cloud framework works for processing IoT data, right? So mostly mostly we'll discuss sensing based solutions, then how the communication happens, how the data will be gathered and stored in a central repository such as cloud, then how the data will be processed using different learning algorithms, and how to solve different uh, your problems for various emerging applications, including smart city. So that is what we are going to do today in this session, right? So this is a very common definition, or you can say representation of Internet of Things. So Internet of Things is the network of physical objects. So what are the physical objects which will be part of Internet of Things? They are devices, vehicles, buildings, and other items embedded with electronics, software, sensor, network connectivity. Now, when I say Internet of Things, is it a network? Yes, it is a network. Is it different than the traditional computer network? Yes, it has some similarities, but it is also different than the traditional computer network. If you see here, if I which devices or what are the entities in computer network. So you will see the here the entities are uh, or objects are devices, vehicles, buildings. But generally, when traditional computer networks we say, okay, these computers are connected through LAN, right? And they connect through your a gateway to the internet, right? So that's what mostly computers are connected. The computers may be of different types, right? Desktop computer, laptop computers, and all, right? We say that. But when we say the Internet of Things, here we are saying we are giving importance to real world objects where uh, the real world objects definitely will be integrated with electronics, software, and sensors with network connectivity. So I'm not telling that a tiny computer will not be. What I'm saying, yes, here uh, we are going to use a computing device in Internet of Things, but that computing device will be customized for different types of real world objects. Like I say, a smart chair, a smart door. So that means I'm going to design a device keeping in mind the application, the IoT application, right? So therefore, our orientation is towards the real world objects when we are designing different types of your chips or different types of protocols which will be a part of Internet of Things. So that means what I'm saying, devices, vehicles, buildings, and other items embedded with electronics, software, sensors, network connectivity that enables these objects to collect and exchange data. Right. So that is what we see in this era of Internet of Things. Right. So now this, if you see here, we don't talk much about in traditional network or computer network about sensors. But in a traditional network, you know about network connectivity. So that means a computer can talk to other computer maybe through wired or maybe through wireless. Like you can use IEEE, your Wi-Fi network for connection, uh, for connecting computers with your Wi-Fi gateways and all, right? And as well as you can use wired local area network or Ethernet for the communication. So here also network connectivity is there so that different devices they can communicate. But additionally, what we are saying, we have the devices have the ability to generate data from the environment where it is being deployed. So that is, there should be a sensor integrated with a tiny computer, you can say. And electronic software, these are the your other important component of a IoT device. Uh, so only you are finding one major difference is sensor. Now in Internet of Things, again, these devices, vehicles, buildings, they will be communicating with each other as well as they can communicate through the internet, right? So now a thing can be defined as an embedded device based on a microcontroller that can transmit and receive information, as well as the device, as I told you, may have uh, your some kind of hardware or CPU or some amount of uh, processing power to process the raw data, right? Minimally process the raw data, as well as it may have also software to run the device. So the things can be connected, different things, real world objects embedded with electronics, software, sensors, and network connectivity can communicate among other things or other objects, and they can communicate through internet, right? Now we have understood what is Internet of Things. So then, what are the challenges in Internet of Things? Whether we are connecting homogeneous objects or heterogeneous objects. Now you consider there are different type of devices people use: smartwatch, your smartphone, customized sensor devices to generate different type of environmental parameters such as your carbon dioxide, carbon monoxide based sensors and all, and you generate data from the environment, right? So if you see different type of sensors, then you generate different type of IoT data. So now whether the data will be heterogeneous, yes, data will be heterogeneous. And whether the devices are heterogeneous. Yes, devices are heterogeneous because they are designed keeping in mind the real world applications. So when you are designing a customized device for a specific object or real world object, like a smart chair, for your application like a smart fridge, a smart door, right? A autonomous vehicle, smart vehicle, or you can say autonomous vehicle. So or UAV, right? Unmanned vehicles, right? Where the your uh, vehicles move without any human intervention or minimal human intervention, right? So those are different type of devices. They're also device level also they are heterogeneous. So sensors are heterogeneous, devices are heterogeneous. Similarly, whether the network is heterogeneous, whether some of the IoT objects, IoT devices communicate through Wi-Fi network. Some of the IoT devices communicate through cellular network like your 4G network and next generation network. So some of the IoT devices they will use your different communication standards. Therefore, the bandwidth for data communication will be different. So that means you are dealing a network. You are dealing a network where the link bandwidth also may vary, right? So that means the devices, so network is also heterogeneous. So devices are heterogeneous, different types of sensors deployed for different type of applications. You generate different type of data, right? And the data also, IoT data may be also noisy, right? Now, so there, and network is also heterogeneous. So you are dealing a network such as the Internet of Things. Primarily, it is heterogeneous in nature. When there is heterogeneity, you have a lot of challenge, or we face a lot of challenge while designing your devices, network protocols, your processing the data when you are dealing with your heterogeneous data as well, right? So that's what that is a key characteristic of Internet of Things. Okay. So you can stop me if you like, or I will stop after 10-15 minutes if I can take some questions if you want, or you can also interact. So machine learning is a field of computer science that uses techniques, algorithms to give computer systems the ability to learn, right? So we'll see that what are the different applications, and for IoT, then we'll understand rather than going to a specific algorithm or something that you can study by yourself. So how where the machine learning will help, right? So coming to machine learning, it is a field of computer science that uses techniques, algorithms to give computer systems the ability to learn. Now, is it necessary for us that the device should learn in IoT? Yes, when we are saying that the device should autonomously work, device should take decisions in IoT. So what we are expecting, IoT devices should not be some simply devices only to receive data and send data. The devices also, some of the IoT devices also should take decisions. I'm not saying all the devices should take decisions, but you have to design the network in such a way that the network should take decisions autonomously, keeping this heterogeneity in mind. That means some IoT devices may be having limited resources. Some IoT device may be having some amount of additional resources. Some gateways where you can have you can afford some amount of processing power, storage. So you have to analyze the entire IoT network. Then you have to uh, design the network in such a way that the network should work with limited human intervention, right? Or no human intervention, you can say, but it is better to tell limited human intervention. The network should work at a large. So then machine learning will help. Now, machine learning gives IoT, and which are part or the other machines in you can say that IoT or IoT where IoT is integrated into different type of machines like mechanical machines and all. I will discuss about that. Machine learning gives IoT and those machines a brain to think. So when if you are designing a smart machine, so you see, you take a small example. You can say that you want to design a smart refrigerator. So when you are saying smart refrigerator, you have to define what are the functionalities the refrigerator will be having, and which of the functionality you want to automate, and which one where the device itself also should take decisions. Suppose I say there is a tray in the your refrigerator. The refrigerator itself should decide whether the tray is empty, partially empty, or tray is full. So the device should get the data and do some amount of processing within its. Definitely you have to design such algorithm which can be executed in that particular IoT device, keeping in mind the resources available, right? But which functionality you want to make it or your provide some kind of autonomy to the machine to take its own decisions, right? So therefore, machine learning gives IoT and those machines a brain to think, which is called embedded intelligence. Now, we are thinking, we are motivating ourselves to your what type of your smartness or what type of intelligence we want to put into a mechanical machine or any machine in general. So that as a user, as a programmer, you have to decide. And now how this why this machine will be a part of IoT, because you can operate this machine through the internet. So these machines also these machines will be entities of the Internet of Things network, right? So you can remotely operate the machine can take its decision. Machine through IoT based sensor, the health of the machine can be studied over a period of time. The wear and tear of the machine can be studied. So that, and based on that, the machine also should generate different type of alerts, so that your even if you are not present in front of the physically not present in front of the machine, you can access through the those responses you can access through the internet things, and as well as you can regulate it also, regulate the device. So if you have when you study machine learning, so there are different types of learning. I'll not go into the learning individual algorithms, but you can study. There are a lot of materials available. So I'm going to the nature of the algorithms. Then whether we can use them or not, while discussion you can understand for various IoT applications. Right. So you have supervised learning. What you do in supervised learning, the algorithm needs leveled data set for learning. That means you have known your input output to learn, right? So then what type of however we can use this type of supervised learning, where we have some level data, classification of network traffic. So there are various type of applications, various types of network data we will be getting. So how to classify them in such applications, and also it happens in a different type of IoT networks. Different type of network traffic can be classified. Usage of machine learning for segregating the IoT traffic. Machine learning for classification, various classifiers are there. So SBM, NN, decision tree. So you can go through different type of classifiers to do apply on IoT data. So you can also do IoT device classification. There may be various devices in the periphery. So there may be somebody may be using smartwatch, somebody may be using customized IoT nodes to generate different type of sensing operations, generating data from the environment, and healthcare sensors. There are various types of sensors are there in your periphery. Some different devices are performing different types of behavior, right? By analyzing such network traffic, whether you can classify, so these many this type of IoT devices are there in the periphery, or suppose whenever you say that sensors and all, we think about sensors large scale network. That means we are not sticking ourselves to design only one device to generate. Suppose you say pollution you want to monitor, definitely you have to put or you have to deploy sensors in a city. So in a large scale you have to deploy. You want to monitor different type of sensor networks under the sea. You want to deploy sensors your near to your international border, and again you want to access them through access your the data through the internet. Whether all these devices directly communicate or they will communicate through a gateway, that is up to you how you are going to design. So primarily before this internet of things and all, people were working on how to design different type of autonomous wireless sensor networks. So there are so many protocols. After that, mostly we see this internet of things, mostly providing various types of customized solutions. So IoT device classifications, and it may include not only identifying the ID of the device, not necessarily different type of behaviors, traffic patterns. So many kind of analysis we can do when devices are there in your periphery, and they are also generating different type of data. Okay, so an unsupervised model. So when you use, then definitely you don't have exact. This is opposite to supervised learning. As you know, in this no need of level data where the algorithm try to extract features or find patterns on it. Right. So basically, through clustering, a different type of similar clusters can be generated. And also, this is one of the good example is anomaly detection in any kind of network, including IoT network. Also, if some node is behaving or deviating from the normal behavior, so that node may not be part of any cluster, or you can find out that few nodes may be separated and their behavior is different than this, right? So various kind of anomaly detection also can be performed using unsupervised learning. And more interestingly, you might have heard about reinforcement learning, right? So when we don't have your level data, you can say reinforcement learning is a machine learning uh, which allows the efficient observation of surrounding. Now, whether learning can happen when an agent your takes actions and interact with the environment. So this learning happens when interaction happens with the environment. So reinforcement learning is a machine learning which allows the efficient observation of surroundings and consistent learning behavior to a learning system in order to enhance the frequency of cumulative incentive and reward. So what intelligent agents do, they take actions in an environment in order to maximize the notion of cumulative reward. So whenever they take action, they basically whether from that action there will be a reward or there will be a penalty. So whether you can say there is a success or there is a failure kind of thing, or you can say reward will be given for each if the action is fine, if there will be penalty for that action if it is not appropriate for that application, right? So this is learning. In reinforcement learning is via experiences, learn from the interactions. So in reinforcement learning, or you can say in this learning happened with the trial and error primarily mechanism similar to human learning, right? So we take some kind of action, whether it is based on success or failure, there will be reward or penalty, right? It is also known as reward based learning. And primarily when you have smart robots in manufacturing unit, this type of reinforcement approach will be used. Smart IoT devices will communicate with other devices autonomously, right? And which devices should communicate, when they should communicate, whether it is effective to communicate with other device with least delay or not, right? Whether the deadline will be some application they are running, or whether the deadline will be met or not. So therefore, you have to understand what you are going to, what will be the output, what you are expecting from the system. So based on that, this kind of reward-based learning will happen. So it is about taking suitable actions or action to maximize reward in a particular situation. Reinforcement learning differs from supervised learning, as I told you, is not needing leveled input-output pairs. So various other applications where we see this reinforcement learning, navigating the robots and UAVs when they move and they have to take different types of paths, and even they are taking different paths, and whether there will be reward or penalty that have to be, and finally there should be cumulative reward for that, right? So which action will be beneficial, which action will appropriate actions will be taken. Playing computer games such as chess, video games comes under this reinforcement learning, right? There will be various possibilities. You are tracing the based on trial and error method that which possibility or which path will be beneficial or the reward will be there. You have to follow that. Network routing in multi-hop network. There will be multiple routes from between a source and destination. There will be multiple route between source and destination, and then which route you should follow so that you want to provide least delay or such type of criteria you have to fix, or shortest path or whatever it may be. But finally, the deadline you will be met. There are various parameters, not only shortest path. There are various other real-time parameters like delay, deadline to be met, and all, right? So where this also can be applied. Device to device communication. So as I already told you, so various type of devices, they should communicate to achieve a common objective based on the application. Now, these are the few we have understood that what are the Internet of Things, and what are the different categories of machine learning, and what we are expecting from the when we are trying to implement machine learning, what type of benefit we'll get, right? And or what type of smartness you can provide to IoT devices. Okay. So now sensing human interactions. That now why we want that this IoT should be there, or IoT should be integral part of for various emerging applications. IoT technology mostly integral part of various smart applications, because we want various real world parameters. We want to sense the world. Sensors can enrich human interaction, right? So now, like say, there's a blind person who can't see. That means, can you provide sensors so that you can provide some kind of your intelligence to the person through the sensor, some input to the person so that the person can walk. Sensors can enrich human interaction with the surroundings. Sensors create a more interactive world. So these are the prime motivation behind using sensors. But when you want to deploy sensors, you get data from a particular sensor. Is it enough that one sensor data is enough for an application? Not necessarily. A group of sensors must be coordinated with each other, and this data, IoT based data, must be sent to a central repository where we can process the data. We can generate different type of patterns using machine learning and all. Then it will be more, you can say, more interactive the application is. So primary goal is sensing an object, communicating with other objects, definitely with various kind of efficient communication methods, analysis of sensor data, central unit such as cloud. So that means we want to collect the data from various sensors. Suppose I take the example of a parking lot. So you can see in this parking lot, there are some open spaces. So similarly, suppose there is some open space over here also, right? So now how many open spaces are there in this parking lot? We should generate the report autonomously from every parking lot. So suppose there are different parking lots in a city. So that means we want to generate the reports for the parking lots about the whole city. So then we want to push the data to the cloud, and we should process here and generate different type of patterns based on our requirement. Right now, whenever the user sends a query to the central unit or cloud, then the different type of customized reports should be provided. Somebody is traveling towards this parking lot or nearby, how many parking lots are there, whether when the person reaches that parking lot, whether space will be available or not. That means you can understand now machine learning comes to picture there to get these decisions, right? So only communicating, sensing and communicating is not enough. We want to process data, we have to analyze data, and we have to process data to generate different type of patterns. Controlling an object remotely through the internet. So not only we want that from sensors we generate the data, store the data, but this generated data must also be uh, processed, and based on the decisions, your if there is a your remote operating required, or if a user wants to operate remotely, it can operate an IoT object which is deployed on the field. Suppose I say agriculture. In agriculture, agricultural drones are there. So agricultural drones, when you have deployed remotely, also the user wants to regulate it, control it, right? So based on the data whatever available, based on that the different type of reports or patterns will be generated. From those patterns and all, how it will be operated will be decided, and it can be controlled by the users. So when we come to this IoT, then we have to also understand what are the limitations. When we say that IoT node, and in the IoT node we have a sensor which generate data, and it has a communication unit which transmits data. It has some amount of processing power to process some minimal amount of processing on the raw data. Then it transmit the data. So that means sense the data, then after processing minimally or whatever based on whatever required, the raw data will be sent to the, or the data will be sent to the your nearby device or to the nearby gateway, and through the gateway it will go to the cloud. If directly this node is connected to is having a gateway, you can connect to the internet, that is fine, right? If not, then it will send to another device will send to another device, and there will be one your gateway through which the data will be uploaded to the internet or will be sent to the internet. So all types of mechanisms are possible based on our requirement. So what are the limitations? Limitation of these devices, primarily these devices are wireless. Most of the IoT devices, sensor nodes are wireless devices, right? And then what is the limitation? Limitation is limited energy. They operate in environment wherever we deploy, right? So they communicate through wireless, and they have limited energy, onboard energy or battery power. They have limited bandwidth to operate. In mostly in sensor network and IoT also we use your standard called IEEE 802.15.4 Zigbee standard for communication. So these wireless standards will have limited network bandwidth, right? So with limited network bandwidth, you have to regulate or you have to appropriately distribute the traffic so that you can perform a task or application requirement to be fulfilled. So limitations are also there. You have to keep in mind while designing algorithms and protocols. All layers must be energy aware when you are designing protocols for various layers in TCP/IP model. As you know, physical there are, if you take a 5-layer architecture, physical layer, your data link layer, network layer, transport layer, and application layer. So if you take a 5-layer architecture like TCP/IP model, then all layers must be energy aware. Whenever you are designing a protocol, communication protocol belongs to a specific layer. That layer must, that particular protocol belongs to that layer must be energy aware or energy efficient. It should know how much energy it has and how much it can operate. So energy efficient, reliable solutions are required. And if you are doing a data forwarding, network routing kind of things, sensing and sending the data and collecting it at a central point, that is also you have to, those kind of methods for data forwarding methods must be energy efficient and reliable. And you have to, if you have a large scale network like a wireless sensor network kind of thing, right, where you want to push the data through a sync node to the internet, right? Primarily, those are known as wireless sensor network. Prior to this, generally, that is well known as a wireless sensor network, large scale sensors deployed, and a sync collects the data where all the sensors are not integrated or will not have the capability to directly communicate with the internet, right? Some of the nodes will be connected to the, or you can, one gateway, a central gateway can be connected to the internet to gather the data about this region, right? So then lifetime of the network in such a is important, and network should run for longer period. Okay. So in IoT nodes also, node level, if you take IoT node, right? So that node also should be energy aware. It should operate longer period device. So network wise, people also define lifetime of the network. You can also define the lifetime of the node as per your convenience. So careful resource management is required because this Internet of Things, it is a resource limited network. This type of networks are resource limited networks. So carefully resource management is required. Transmission power, bandwidth, um, onboard energy, processing capacity, storage, keeping in mind how much available and constraint you have to design your algorithms and protocols. So various sensors are there. Whenever you deploy sensors in traditional sensor network and all, sensing, some nodes do sensing operation, some nodes do relaying operation, some nodes do sensing and relaying operation, some nodes will be in backup. If you deploy sensors in a typical wireless sensor network, some nodes also can be kept as a backup. So when there is no other sensors in that region to sense data and they deplete their energy, then these backup nodes also can be activated. So there are various methodologies uh, to sense and sense a region. So if you want, why you want to understand this deployment patterns and all, because you see, whenever you deploy these sensors, generate data, then you have to take your different kind of decisions. How many sensors are required for this deployed region, whether the every part of the region is covered in the sense, the when you take a node, it will have a sensing region, then the node will have a communication region. So primarily we take sensing region is lesser than the communication region, or typically people assume that. So, and this is the sensing area. A node can sense from this region, and a node can communicate uh, within this region. So that means if there is another node here, whatever this node is sending, it can receive. But if a node is here, it can't receive directly from this. Okay, so this is your communication region. So this is your sensing region. So therefore, when you are planning a deployment, you should plan in such a way that every area, every unit of areas to be covered by at least one sensor. So there are various deployment patterns. Some people work in, do some research. How many sensors are required for a given geographical area, right? So therefore, you have communication range as well as transmission range, as I told you here. So you can, the nodes when you are deploying in IoT, so these nodes may be mobile or stationary. So the nodes, whenever you deploy the nodes, suppose in a region, right, and some nodes may be mobile nodes, they will be moving in this region. Some nodes may be static. That depends on what type of architecture, what type of applications you are dealing with, and uh, you want to generate different type of sensing activity from the region, and you want to send the data to a sink where it may be processed, right? So then IoT nodes also, uh, this is a typical sensor network, right? In IoT nodes, for IoT nodes also, some nodes may be mobile, some nodes may be your static. Suppose you deploy some sensors in a smart object, in a smart object, like your smartphone. Smartphone is mobile because you move, the mobile phone moves. Different type of IoT applications, if you are running in the mobile, then the mobile will be treated as device which is moving with time. And similarly, some static nodes, like you can deploy sensors in your campus to generate different type of data from the environment, like any type of poisonous gases or pollution level, temperature. So those type of thing you can do, and those IoT devices can send the data to the internet. Okay, so then you can, based on the application, you can choose some of the devices are mobile, some are stationary. Now, what about the events? What type of events you want to measure? Static event like temperature, dynamic events like target detection. So suppose I say you have this is the boundary wall. You want to deploy some nodes here for object detection. If there is infiltration, somebody is entering, right? It should be detected, right? So then this event, basically it will be a target detection. That means if somebody is moving, so it is whether anybody entered or not. If it has entered, then it is going through which path. So all these nodes, they should communicate with each other, and they should adjust their sampling rate, and they should process that to find out the uh, trajectory through which this object is moving. So then that is a dynamic event. So that means whenever whenever there will be a fire, it is not known. Wherever there is a person is in you are entering uh, uh, into one restricted area, entering into a restricted area, that is also not known. It is dynamic in nature. So this type of applications for which you want to provide a solution, right? And deployment, when coming to the node deployment, you can place manually and you can scatter the nodes randomly, that depending on the your application. So if you want to monitor the what type of what are the things happening under the sea, and what type of, whether there is a fire in a deep forest, like different type of forest, there will be fire. Then what is the spread of the fire in the forest, whether it is spreading in this direction, this direction, this direction, and all. For that, what you have to do, you have to deploy sensors, right? So primarily, even without internet, if also you can deploy the sensors inside a forest, and the sensors, after deployment, they can self-organize, they can discover their neighborhood, they will establish a network, they can communicate with each other. Finally, the data will be reached central gateway. Then using the internet, the data can be uploaded. So the various methodologies are there, right? So prior to this internet of mostly this type of applications were known as, mostly where we use wireless, primarily wireless sensor network for underwater sea monitoring, your deep forest monitoring, deploying in a desert, deploying sensors in the pole region. So various kind of application it has. But finally, this data to be uploaded, and where centrally it should be processed, right? Okay. So, but when we are coming to this only concentrating on Internet of Things, so there what we want, no, those objects must be, objects can communicate directly with the internet, and objects can regulate through the internet. Objects can sense data also. So then you can have hybrid also. That means some amount of sensors in this primarily are hybrid, in the sense that you can also use some amount of this wireless sensor network technologies, also bringing technology from idea from Internet of Things. Then you can combinedly also provide solutions. Okay. So any questions so far?
Good morning, sir.
Good morning.
Can you again tell about the self deterministic in the node deployment? First one is deterministic, second one is self-organizing. Can you repeat again? Self-organizing, how can we use it?
Okay, right. So now if you see, there will be so based on your requirement, so you have to
Sir, can
your
we use in the field of HANET, self-organizing method?
I'll come to that. Okay. So now you can use these. When you are doing node deployment, definitely you are deploying nodes based on your application, right? So whether various application already I told you, right? Typical wireless sensor network applications, right? Now, when you want to deploy the nodes, then either it will be manually or scattered randomly. If you say manually, as I gave you example, this is manual kind of deployment you see. Now, suppose I put all these nodes in a grid. It is manual deployment. I will have a grid. Every grid point will have one sensor. So various methods are there. Then you see that you can measure this distance and all, and based on the geometry, you can place the or at these points you can place the nodes. Then there is a manual deployment. Then every node knows which nodes are its neighborhood in its neighborhood. That means if you take this node, this is the neighbor of that, this is the neighbor of this, this is the neighbor of this, right? Because you know the communication range. Already I told you here the communication range. You know this communication range. Means what I'm saying, it is ideal, some kind of theoretical range, but practically range will be may not be in this regular shape. But if you know this communication range, then you can deploy suitably in this, or you can decide this grid accordingly. Now, when you are deploying randomly, now this is a given area. You simply from like a deployment in a forest, you simply throw it from an helicopter, right? You simply throw. Now, when you have thrown, what you see here, these nodes, when you have thrown these nodes, this fellow doesn't know who are the neighbors, because you have not manually did it. Because which node will be the neighbor of which one, you don't know when you are throwing. Keeping in mind that this much area is there, I have to distribute some of the nodes, you have simply thrown it. Now, these nodes should send some kind of control messages in its neighborhood, and they should discover its neighborhood. If every node should do that, and if every node will find out its neighborhood, then you can construct a adjacency matrix, and in the adjacency matrix, which neighbor, which node is having which neighbors, you can draw it. Now, if this information is somehow passed to a central entity, then the central entity also can draw this topology. That is one thing. Second thing is, now when this node discovers its neighborhood, that means there are two neighbors. They replied to its control message. Then this fellow knows, if I send a data, some sensor data, there are two sensors in my neighborhood, they will forward my data towards the sync node. Similarly, this fellow also will have some neighbors. Accordingly, it will go. Just think of a plodding kind of thing. So data will reach this destination or not. So now, mostly this, you have not done anything here before deployment. After deployment, the nodes discover their neighborhood. Based on neighborhood information, they will find out their the network will be discovered, or you can say self-organized, and the data can be forwarded. After that, so many other things will happen. Once the neighborhood is there, then if there are multiple paths, then you have to choose the best path. Those things will come later. But this, whatever you see, this nature of this your deployment, after that they discover their neighborhood, they find out which are the neighbors in its how many nodes are there in its neighborhood. So those things, you are building the network and in a self-organized manner. Is it clear?
Yes, sir.
Okay. Any other question, please? Okay, fine. So more things in your, what is the importance of IoT? We have discussed that various applications are there where we want IoT solutions. See, it is not only a single technology there in the IoT. IoT is, as I told you earlier, different type of sensors, different type of networks, different type of data, different type of algorithms to process the data, different type of technologies or different type of protocols we use to communicate between devices. So mostly it is some kind of heterogeneous. This is a you can say this is a collection of various kind of heterogeneous technologies, right? But finally, our aim is this. As my first slide when I started discussion, what I told, our aim is what? The data should be sensed from the devices, and this data to be uh, communicated, or these devices should communicate with other devices, and other devices should communicate with other devices. We should have a network. We should collect this data centrally. We should process that data. Then only the requirement of the application will be met. So there are, as the day progresses, there are the number of IoT devices are also increasing. Billion of things are connecting to the internet recently, right? So various applications. You see, we have wearable healthcare devices, and various performance monitors we want to implement, um, and connected vehicles. So that means using various type of healthcare devices, we want to take various decisions based on the healthcare data, and whether the healthcare the person is in good condition, health of a person is good condition, bad condition, generate reports and give to that person. Smartwatches and all people are using, right? Connected vehicles. Earlier, you were asking about vehicles, and one of the participant was asking about vehicles, connected vehicles, how the vehicles communicate autonomously to perform a task. What is the task? What is the congestion level? Whether there is an accident on the road or not? If there is an accident, what to do? Right? I have some case study. I'll show that also. Right? So if there are accidents on the road, what type of decisions can be taken? How the IoT technology can be used? How smart decisions can be taken? So smart grid, you might have heard about smart grid technology, right? So primarily, a consumer should know how much it is consuming, how much electricity is consuming, and also how to distribute the overall your electricity in a large geographical region, or in a city, or in a state and all. Smart homes. So you have to define what is smart in the home. Whether your fridge is smart, your TV is smart, your door is smart, right? You have to decide that. Then definitely, then you have to embed some intelligence into that. And connected manufacturing, various kind of in manufacturing sector. So various kind of things also you want to make it or provide some kind of autonomy to that. So what people are thinking, mostly Internet of Things will change the way we work, we live, we play, we learn, right? So things are changing, and we want to provide some kind of decision making to the devices at large. So, Internet of Things is the intelligent connectivity. Earlier, we were discussing about sensors will generate data, it will send data to others, and data will be collected. And then what we are saying, no, no, not only collect the data, you process the data, take decisions on the various patterns, right? Where machine learning comes to picture. The Internet of Things is the intelligent connectivity of devices. I'm saying in the very generic sense. Intelligent connectivity means it is not only communication is intelligence. It is also whatever the data we are generating or we are getting from the environment, processing it, generating different type of patterns, and using it again coming back to the deployment region and regulating those devices. So Internet of Things is the intelligent connectivity of physical devices driving massive gains in efficiency, business growth, and quality of life. So if you see the Internet of Things, so what type of solutions you want to provide? We want to provide customized solutions. When we want to provide one IoT solutions for a sector, we want to provide customized solutions. What mean a customized solutions? Based on the requirement of the agency, based on the requirement of the institution which wants to build one IoT solution. Researchers have designed and developed, or researchers have designed and developed various hardware and software platforms to support IoT applications. Application, especially IoT, is application-oriented research. Then customized development is required for that particular application. So an IoT solution may not work in another, suppose an IoT solution designed for one particular application may not work for another application because the environment, the application is different, right? So therefore, what I say, this is mostly application oriented research. You have to understand the environment for which you want to provide one IoT solution. And when you say that you want to provide an IoT solution, then what are the things you have to look into? You want to look into what type of sensors you want, what type of network standards you want, what type of network gateways you want, what type of repository or cloud you want, what type of machine learning algorithms you want to process the data. After generating the patterns, what type of decisions you want to provide to the users. Now, users want to regulate these IoT devices based on this data processing results. Again, whether they can be, the devices can be regulated remotely or not. So all these tasks. So then these tasks depends on, or it will vary from application to applications. So various network technologies people use. Wireless sensor network, part of IoT, Wi-Fi network. Also people use IEEE not 2.11 standard for Wi-Fi network. Wireless sensor network people use IEEE not 2.15.4 GB standard. Cellular network people use various cellular standards where IoT devices communicate through cellular network. Wireless mesh network is also wireless network. Vehicular network. There are various kind of your networks are there. Heterogeneous network units employ RFID sensors and other smart terminals to get the sensing information anytime, anywhere. Now, this is, if you primarily see how this IoT works, this is the sensing layer where various types of sensors we are showing. We are deciding which sensor will be used, whether it is a sound sensor you want, whether you want a temperature sensor, or a humidity sensor for your application, or camera sensor for your application, or motion sensor. So you have to decide which sensors are required for your application. After that, you have to build a network. So whether this based on the communication range of the devices. So whether it will be single hop communication between the gateway and the device, or it will be a multi-hop communication between the devices and the gateway. So after that, you have to work for the networking part. Then you have to upload the data to a central repository such as cloud. Here you are going to process the data. This data will be processed and generate different types of patterns. And various other applications you can see. Application, this is basically device connectivity and cloud networking. And why you are designing device, you are deciding different type of sensors and all, because you want to deploy sensors, generate data from different type of sensor nodes and all, right? So what are the different applications? Vehicular network generate data from the vehicles through camera sensors and all. And there are various type of your users who use mobile phones through which they generate different type of IoT data. They send to the cloud, maybe through satellite network, maybe through a direct gateway. So IoT devices can connect to cloud server by internet or satellites. IoT devices reliably transmit urgent events and data in real time to remote monitoring the center for processing. The monitor at the central server intelligently processes and analyzes a large amount of data to achieve the smart control of objects. Right? So primarily what we are aiming, we want to do apply machine learning over at this layer. So various applications, industry, agriculture, your transportation, your smart home, your security, various kind of security activities with surveillance camera and all, then various healthcare like ambulance and all. So various kind of IoT applications are there where people use, and this data will be sent through some gateway, and through the internet it will be uploaded to the cloud. So where you want to apply your different you want to process the data by applying various machine learning algorithms. So IoT data characteristics, if you heard about big data, large volume of data, variety, velocity, similar data quality, about accuracy, dynamicity, redundancy, similarly data usage, what is the semantic of the data, whether about completeness of the data, whether noiseless or not. So those are the IoT data, various data characteristics when you are generating data from your different applications. So this architecture, what you see is centralized architecture. Your IoT cloud is centralized architecture. So here, what you do, one centralized architecture, if you see, we are collecting the entire data or gathering data at the cloud. We are collecting and storing in the cloud. You can say most of the data management and all happens at the cloud. Now, this is centralized architecture. That means IoT to cloud. That means mostly IoT network, mostly they are not taking much or they are not doing much data processing. But there will be applications where we can say peer-to-peer architecture or decentralized architecture. IoT applications talk to another IoT applications. So this is one IoT application, this is another IoT application. That they can talk to each other. And not only they can talk to each other, they can communicate within itself also. So definitely based on capability of the IoT nodes, they can how much data they can process in each your IoT network based on the resource availability there. So why we are you are uploading the data to the cloud? Why you are sending the data to the cloud? Because we have a large amount of storage available centrally, and the data processing and machine learning models needs your large amount of data. So if we are pushing it to cloud over the period of time, then what happens? We can analyze the data at the cloud. But in local decisions can be, that is mostly you take the global decisions. Local decisions also can be taken by individual IoT applications. And IoT applications also, one IoT application can also talk to another IoT application so that without intervention of the cloud, then that will be your peer-to-peer architecture. Okay, so that means when I say this, you see there are different type of applications. It is healthcare, right? So healthcare and smart home, or healthcare transportation. From transportation, some kind of data required about the road network. Suppose congestion level. That data is also required for the ambulance, where the patient is moving. So that means if these two can communicate directly among each other, then that will be peer-to-peer architecture. Now, what is it showing? They can communicate through the cloud. Through the cloud, again, decision will come back to the other. So it is basically centralized. So the other one is your peer-to-peer architecture. Both the architectures are there, but primarily now this IoT cloud architecture, so many people are using because of its simplicity and getting the data centrally. So many people are using that, right? But there are applications where smart objects they are moving, right, and they should take some decisions and fly there itself. So some amount of your processing or some kind of intelligence also we have to embed into that particular application. Okay. So you coming to the wireless standards, already I told you IEEE 802.11 Wi-Fi. This is Zigbee used in your sensor network. These are the your different wireless standards people use, right? These are the cellular standards, and this is another standard, name of the IoT hardware platforms. Now, what are the different hardwares you use? This is a very well-known hardware. You probably heard about Arduino. Arduino boards they use to integrate different type of sensors into that, and through a wireless gateway, data will be sent to the cloud. Similarly, Raspberry Pi this is another IoT device where sensors will be integrated into this. Different type of sensors. Already I told you. There are many more such devices are there to prepare or to design one IoT device for a particular application. So there are various people work in a different domain in IoT, right? So some people work mostly some people work mostly in application side. When I say application side, they want to understand, or most of the people basically because it is application oriented research, mostly whenever they want to design some products, they have to understand the applications. So for which type of, it is an agriculture application, it is a smart vehicle, uh, based on the application, they have to understand, analyze the application. So for designing different types of methods, right? So because your IoT is more towards application oriented design. Okay. Now some people work on your designing system on chip, different type of your customized your microcontrollers people design, customized chips they design, system on chip they design for various IoT applications. And people also work on mature internet protocols. So when I say that there are your different layers, physical layer, data link layer, network layer, transport layer, and application layer. So in TCP/IP model, then different people work on improving the performance or efficiency of different protocols. Such as I say, IP is a protocol, right? So now whether security is also required for IoT application which you are going to design. If you say yes, then you have to provide one IP security protocol. And what type of IP security and all, again you have to analyze that type of adversary attacks, then that type of protocols also can be designed, right? So therefore there are different layers are there, right? So for different protocols are there. So for that some people are working on this kind of things. And you need efficient wireless connectivity, or you can say good wireless connectivity, you can say, for communication. Like you are using 4G network, next generation 5G network, you will have good your communication channels so that IoT devices can communicate with each other. You have to provide good bandwidth for communication, maybe uplink or maybe downlink. And some people want to use or to provide different type of cloud network services for IoT. Right? Already I have introduced about that architecture where the cloud is basically helping us, right? And because this IoT data is heterogeneous and huge volume of data and data is heterogeneous, uh, so it fulfills most of the criteria of big data. If you are a researcher in the big data, so here also various kind of analytics can be done on this. Any questions so far?
Sir, how can we use reinforcement learning in the case of routing? Because reinforcement learning supports reward and penalty.
Yeah. Suppose uh, uh, you have three paths, right? You have three paths. So which path you will choose? Suppose prior information about network traffic is not given to you, right? So therefore, it will attempt all the possible paths. So then your some paths will provide it success, some path will provide it failure, right? So based on that, based on the traditional reward and learning method also, it can be done. There are a good number of research papers also. Uh, some researchers are working in applying this learning automata kind of approach this in this routing. Is it understood or any more? You can, if you
Yes, sir,
want,
understood.
yes,
Thank you.
specific kind of algorithm you can choose actually. Because if you don't have routing information in routing tables are not there in such cases.
Sir, one more question I have.
Yeah.
Sir, how can we detect the malicious node in a particular area?
Okay. So malicious nodes they have different type of behaviors, right? Suppose as you can say, so there are different approaches for that. Suppose let me give you an example that uh, if there are 10 users in your periphery, or there are not 10, maybe in a seminar hall there are 100 students sitting and all are using some mobile phones or something. They are interacting or they are sending some traffic, some data through the gateway which you have installed, right? So now if we can collect this network traffic information. When we analyze it, we can find the deviations. If somebody is doing some kind of behavior which is deviating from the normal behavior, like so then we can do that also, like anomaly detection kind of thing, where some behavior, if you are doing clustering, some clusters will be similar. There you will find a few, maybe one or two users in the seminar hall, they are doing some other kind of activity. So that can be treated as anomalous. That is one. Second thing is uh, malicious activities also can be classified. So that means then you have to say whether a node is malicious or not. So that means every user you will have, you have to analyze every user's behavior, various based on different type of features. Then based on the features or different type of features set from that user's behavior, you can decide one threshold and you can also classify them. Both can be used based on what type of data you are there with, whether you have ground truth with you or you have label data to train your model to decide whether a node is malicious or not, or you can also find out abnormal behavior where you can apply also this kind of clustering. I hope it is clear.
Yes, sir. Thank you.
Yeah. Any other question? Okay. So let us understand there are some emerging applications and what are the different type of smart city applications where we need solutions. So if you see application, various kind of applications, you have to understand what type of application. Earlier, although I told you in the context of sensor network and all, mostly it is some dynamic object tracking and some continuous kind of monitoring and all. So you can also categorize different type of application specific traffic. Some traffic is event centric, some traffic is continuous monitoring, some traffic priority levels. That means some network traffic are priority level. That means the applications are prioritized applications. Uh, Bandwidth guarantee, you have to provide bandwidth guarantee to some of the applications like your some kind of video traffic. So video and audio kind of traffic. So you have to provide some amount of bandwidth so that the application should run. So that needs some kind of guarantee kind of thing. Okay, whether you can provide or not, but that is the need of the application, right? A two-way or single-way communication. In the application, only you want to send the sensor data to the cloud and process that one and provide some patterns or generate reports for the user, or sensor data will be sent to the cloud as well as users also wants to control this object remotely. So that means that is coming two-way communication. So for your application, what is required, you have to decide. You want to take local decisions or global decisions? Which one is required? Again, comes from the application. So you have to understand properly the IoT application for which you are providing providing an IoT solution. Okay. So as you might have heard about high-speed trains, where these IoT solutions are required, route optimization is required, efficient route finding is required. If there is an accident, when some wear and tear is there, well in advance it should be known to the your train so that it can reroute itself if possible routes are available. Otherwise, it should take other appropriate actions. Critical sensing or object detection is part of this, and through the internet a lot of communication on fly should happen for this type of high speed train, and as well as passenger comfort, web services. These are the additional things required for the users who are moving, who are traveling through that. When you are managing vehicular traffic in a city, congestion monitoring, traffic guiding system is essential part of IoT application. Vehicle parking, parking lot management, as I told you, how many parking slots are there, at present how many is there, in future how much will be there, a lot of predictions are required. And also people use drones in precision farming, where you use IoT based technologies, right? And it should be smart drones, autonomous robotic lever, all those things used in agriculture, or plant and soil monitoring in agriculture through sensors, all those parts of the IoT in agriculture. Now, we have also done some work in this IoT domain, and especially providing some solution to this emergency vehicle routing. If there is a your temporary accident or an accident on the road, so how to reroute the traffic? So well in advance, mostly the decision should be taken so that rerouting has to be done. That means if there is an accident, some kind of, if there is a road, there is a two-lane road. So in the two-lane road, if you are moving like this, but there is an accident, right? So if there is an accident, you are here, you should get another route, reroute yourself, right? Because there is an accident. Okay, or there is some kind of temporary road construction is going on here, right? So which happened just recently. So such type of things also you have to reroute the traffic. Okay, traffic congestion in urban areas is a major problem that has a direct or indirect impact on public health and services, right? So when an ambulance kind of thing is moving, so we should find out an appropriate route for that vehicle. The timely arrival of emergency vehicle ambulance to the nearest hospital having necessary specializations is very crucial for the survival of casualty. So, so that is part with that motivation we have to provide some kind of to avoid temporary road blockages. Guiding an emergency vehicle which can avoid temporary and road blockages and congested routes in smart cities. So what we can do, we can have in this solution, you can have vehicles over here where you have users or drivers are here, and you have a data layer where the sensors are generating data from the deployed in the roadside near the traffic post regarding road congestion and all those information, right? And this is a information layer, or you can say it is a sensor gateway through which the data is being uploaded to the internet. And through the internet we want to generate, we have a traffic monitoring center here. So this can be used at the central in a smart city level where we can deploy this OSRM server, right? So there, this data we want to upload, and where we have our database server, our decision support system, where we take different type of decisions, process the data, and then routing information should be sent to the the crowd, or sent to the user or the driver, right? Route request or route reply to the driver, then driver will find out it. So that means data can be generated from the sensors on the deployed at different traffic posts and other part of the road regarding your congestion level and other things. And as well as we'll also collect data from the crowd, like these drivers, other vehicles they're moving. So these people, they know where are the accidents are, or so immediately they can share that information. So that information crowdsource, that is called mostly crowd sensing or crowdsourcing. Through the cellular network, this one who are using this application, they can share also data, whatever they see in their neighborhood. So that all data also will collect at the traffic monitoring center. We'll collect that data through sensors. We'll also collect the data from the crowd or the people who are nearby to that your road blockages and all, right? Then this is your internet layer. This is traffic monitoring center. So this one you can implement wherever you want, your institute level or your smart city level. This can be deployed this OSRM server. So you can go through this in detail how this works. Then this processing is done. Whatever the data, collected data, IoT data, whatever you collect here, and processing is done here, and route information is sent back to the driver to reroute itself. Then the major components, what you see, we have various types of your sensors which sense different type of parameters, and we have crowdsourced data from the people who are nearby to that. They can also send the data through different type of IoT gateways, maybe cellular network, maybe wireless gateway, like that. And this is the your traffic monitoring center, and the congestion aware alternative routes are given to the vehicle. This is basically a high level diagram to understand how it works. So we have used a fuzzy logic based decision support system in this case. So in detail, you can go through the paper I mentioned over here. This is a Elsevier journal, Computers and Electrical Engineering. You can go through this. This paper is published in this journal, Computers and Electrical Engineering, Elsevier. So if you can see some kind of your routes, how it is generating the routes. So if you have blockages, once you get blockages, it will reroute itself. So if you have multiple blockages, it again reroutes, right? So therefore, this rerouting, and if there are temporary blockages here and there happening due to strike, due to accidents, various kind of reasons, temporary blockages happens. These are not only statistical your congestion data, but temporary blockages. So we can use both sensor-based data to basically to provide this type of a solution that to generate congestion data from the road network, as well as we can use crowdsourced data to find out and reroute this type of these things. So there are other smart city projects. You can, if you are interested, you can look into this, like monitoring water contamination in a smart city. So you know that in a city, when you get water your from your or at your home, and so you have to understand whether water is contaminated or not, and also you have to understand if there are different pipes, then water has been contaminated from which place. So those kind of things also people provide different type of sensor based solutions. Okay, and if that information is available, then appropriately a city or the authorities, they can take decisions and to solve that problem. So monitoring water contamination is a one type of problem which people are interested to solve. Uh, uh, um, Here monitoring water contamination in a smart city. Different type of waste management, solid waste, liquid waste. So how to manage these different type of waste which are generated from the smart city, right? And whether what type of poisonous gases are coming from these wastes. So all this monitoring has to be done, right? And appropriate decisions should be taken. So how to manage over this, and how IoT projects also helps in this regard. Traffic congestion monitoring and the decision support system. This already we have discussed a few things about this. How to monitor the congestion level in a city. Not only that statistical data, whatever you are getting from different sources, but temporary road blockages. See, if you want if you want uh, an autonomous vehicles to move, so not only the statistical congestion level data, how many vehicles are on the road is enough. You want what is happening on the road and so many other parameters, right? And what are the other parameters which cause temporary road congestions? That also you have to understand. So you have to do research on that. What are the other parameters also which contribute to traffic congestion, and then you can provide a better solution for various kind of emergency vehicles. Air pollution and monitoring, it is happening most of the time. You know that air pollution monitoring is going on various cities, and people want different type of uh, more sophisticated solutions, right? This also comes under IoT based projects. Smart grid and metering, how to uh, your manage this grid, and your overall how much electricity or power available, how to distribute it is a smart distribution system as well as smart metering system. So the user must know how much the user is using, and how much the user is supposed to pay after a period of time, right? So user must be aware of this. So that means you must know every day how much electricity you have used and how much will be charged from you. If you are using more, based on charging policy, in future you may be charged more also. So therefore, if such a policy comes, we don't know whether it will come or not, but if such policy comes, right, that if you are charging, if you are using more, then you have to pay more, then probably um, you have to use electricity judiciously, or we should use very carefully, right? Smart healthcare. Uh, Urban and rural places, these healthcare activities, as you know, during pandemic also, various kind of your surveillance are required. People, we want to know the health of a person inside the ambulance whenever the ambulance is moving. The ambulance is traveling from one place to another place. During that, you want to know what is happening inside the ambulance. Also, some patients, whether what when they are then admitted in the hospital, also some amount of information also you may want to know about the patient. So there are various kind of healthcare system, not only you want to know, doctors want to know. That is more important here. Doctors must monitor the patient who are admitted in the hospital. Remote monitoring by the doctors, that is more appropriate. That then you want to know, that is fine as a family member, that's fine. But it is more important that doctors must know what is happening and how to remotely monitor the real time your health of a person and in the hospital, and so that appropriate actions can be taken, so that your further patient before going for a extreme kind of condition. Okay. Smart parking lot management, as I told you already, this is basically in smart city. Whenever you are going, you must know where are the parking lots and which parking lot uh, you will be nearer to your destination, which parking lot will be nearer to your destination, as well as which parking lot will, if there are more than one parking lots near to your destination, you must know how much cost you have to pay if you want to park it, whether parking lot place is available or not, how much you have to pay. All this information should be given to you, right? It is required. You can understand by yourself. These things are needed for the smart city, right? This is another interesting is your multimodal transport system, where a person suppose moves from a village to a city. So from where to where the person has to move by taxi, from where to where the person has to move by train, from where to where the person has to move again by auto or again by taxi, so that it will reach the destination. This is source and destination. So now in between the person may move using public transport, the person may hire some taxi or auto in between. So however, the person has to pay least amount to travel from source to destination. So just imagine this is a this type of application for smart city. So whether how much we are providing such information. It is not about one particular type of transport system. Like you might have traveled to different type of your taxi network, right? Where you book taxi and all. Without naming, I'm telling there are various type of taxi vendors you can book. But here it is not about that. It is heterogeneous kind of thing. The person has to everywhere. This taxi network may not be available, right? So somewhere the person has to travel by taxi, somewhere travel by train, somewhere by flight, somewhere by this one. So that source to destination, the person has to pay least cost as well as the least delay also. That you have to find out the trade-off and all. Okay. E-governance system like MIS, GIS kind of systems are required for different type of e-governance system for different type of agencies. Gas filling and management. So where are the gas filling stations and how to manage them? These are the some of the applications in the smart city. That means the driver must know where are the gas filling stations and how much gas remaining in its or how much battery electric. Now you know your vehicles, electric vehicles are coming. So there you have to replace or you have to replace the battery or you have to recharge the battery, whatever may be the technology, right? So where are those stations, right? Those things comes under or you can see, can visualize those projects as smart. So any question? Okay, if no question, I'll move. So your smart healthcare, if you see there are wearable sensors, various kind of sensors. Wearable sensor nodes are those measure physical conditions. Recommended sensors are those that measure the vital sign of pulse, respiratory, body temperature. A central node receives the data from the sensor nodes, which are deployed in human body. It processes this information, may implement some decision making. Now when you are coming to decision making and all, you need this ML your algorithms to make some decision, then forward the information to next your external location. That means whether some decisions you can take locally, how much processing you can take locally, that you have to decide. How much processing you can do globally at the cloud, that you have to decide. So therefore, most of the processing and applying ML, all those techniques should be mostly preferred at the dedicated central node such as cloud. So medical information obtained from the patients must be stored securely for continued use. Doctors knowing the patient's medical history and machine learning is not effective. Means doctors knowing patient's medical history, they have to take various kind of decisions, right? And they can advise the patients what to do, what not to do. Machine learning is not effective unless large database of information are available. Therefore, we should collect this data and store in the cloud, and so that the data will help us to generate different type of patterns. Based on the literature, cloud storage is the most viable method for storing the data, and providing accessibility for healthcare professionals without compromising security is also a concern. So when you are keeping the data in the cloud, the security is also a parameter. So you are keeping patients data in the cloud, then security is also a major parameter. How to provide data privacy and provide accessibility only to the users who are intended to access. So if you see this body area network, you can see these are the sensors, different type of sensors, which are mostly the person is wearing different type of IoT devices integrated with different type of sensors, right? Patients with wireless body area network, and through a base station kind of thing, you can send the data to machine learning enabled cloud. Now here mostly different type of this data will be processed, and general practitioners, nurse, specialists, all these people who can access based on their access control on the devices, on that data, whatever the data you have sent here. So based on their role, your different type of access control can be provided to this data which is stored here. And what they want, they can't access the raw data, right? You have to process the data, generate using machine learning. You have to generate different type of patterns, and that also that different doctors and all, they can access that based on their role. So also data privacy side also you have to work on. So cloud storage, why you are using cloud storage? Because we want to, this is capable of storing high volume of varying data, are essential to a big data healthcare system. So the volume of the data points increases as people wear sensors connected to the cloud storage, and as more kinds of sensors are introduced. So depending on the data, the volume of the data, you can see not only for one person you are doing that, there will be several people will be wearing this type of IoT devices, and as well as multiple different type of sensors they are wearing, right? So those things, all the data will be stored in the cloud. Using the big data that will be rapidly form and continue to grow in cloud, machine learning algorithms can be implemented in the high computing environment of the cloud. So also we are applying machine learning at the cloud, and to basically process this data to generate different type of your patterns and to learn. So this is basically what we expect. Cloud will have enough resources like computation power, storage, where this your large amount of data can be stored and processed. So there are various applications: wearable accelerometer sensors for knee monitoring, monitoring blood pressure, and automatic alert generation for the patient, right? Pulse rate measurement, your also maybe there. Yeah. If somebody is wearing different type of wrist watches and all, you can generate different type of pulse rates and all, right? So there are various applications where this IoT is basically used, and very based on the type of sensor, healthcare is one of the prime application where we generate different type of data and we process the data. We use appropriate machine learning algorithm to process the data, and that will be done at the cloud layer. Okay. Now, this slide will give us how these applications are related to this machine learning. Machine learning is valuable. Machine learning is valuable for accurately predicting future events. Machine learning is valuable for accurately predicting future events in IoT systems. Okay. Now, if I ask you these questions, you will understand, yes, learning is required here. We want to predict, or we want to generate different type of patterns. We have to understand the system, right? Not only that means the necessity of AI and machine learning, you will understand as a whole. I'm telling in general, which road is going to be congested? You want to answer this. Which road is going to, now given a road, you want to find out whether this road is congested in next 2 hours, that you understand how much data you want to process it, including local parameters also. See, when I'm saying local parameter, it is not about how many traffic is there on the road. There are so many local parameters. There is a crowd, there is a strike, there is a some kind of construction. Suddenly, somebody is doing. Some important person is traveling through that road. So these are different type of dynamic factors on the road. These are the local constraints which make the road so much dynamic. Otherwise, you see, then when we see these kind of challenges, then these challenges help us to understand how these autonomous vehicles will move on the road, right? Which road is going to be congested? Which machine is going to be down? Then through IoT based sensor, the health of the machine to be monitored 24/7 to answer this question. Condition of a patient in healthcare, is it deteriorating? Is it improving? Which applications are eating more resources in a smartphone? You are using a smartphone. Which application? You are running multiple applications. Which one is eating more resources? If you know that, definitely you will aware of, oh, these applications are eating my battery or energy, so I have to use the application, or I have to find out alternatives. Which portion of the city will be more populated? Now you see the questions, which portion of the city is more populated? Will be more populated, not now. Presently, what is the condition? Now will be more populated. You see the patterns. Based on that, you find out or predict. Overall, you can see AI and ML will help in this all these kind of things. When you are predicting, it is probabilistic, right? Which portion of the city will be more populated? Which portion of the country will get less rain? Which portion of the city will be consuming more electricity and energy? Depending on so many parameters, how many people are migrants are there, how many people are constructing buildings, right? All such data we need. So if you try to understand, then in general AI and ML techniques, wherever appropriate, which type, you have to find out based on the application, and based on the data in hand, you have to decide what is going to help you. So predictive capabilities are extremely useful in an suppose take some kind of a case study kind of thing in an industrial setting. Predictive capabilities are extremely useful in an industrial setting. By drawing data from multiple sensors in on machines, like I told you, make the machine more smarter and smarter. Let the machine take decisions. Let the machine generate alerts to the users. Users will be sitting, will be accessing through internet. They will be monitoring, regulating those machines. Machine learning algorithms can learn what's typical of the machine and then detect when something abnormal and begins to occur. So as I told you, some processing can be done in the application itself based on the resources available, and most of the things will be done centrally through the internet. Will be collecting the data and will be taking decisions and generating different type of alerts, and so that the machine can be handled properly. So collected data is sent to the server where it is compared with the previous data collected from the machine as well as the data collected from the similar machines. Platform can detect the slightest changes and warn of developing malfunction by the machine. Analysis is done in real time and the results are displayed on the technician's smartphone who is operating that machine within seconds. Right? So that's what various kind of machine nowadays, they are making it IoT enabled devices or IoT enabled machines so that they can monitor the health of the machine as well as your they can control the machine also. Some of the functionalities also can be controlled remotely. So that the data models that are typical of traditional data analytics are often static and of limited use in addressing fast changing and unstructured data. But in IoT, for IoT, it's often necessary to identify correlations between dozens of sensor inputs and external factors that are rapidly producing millions of data points. So in mostly IoT data is heterogeneous. There will be noise and all. I told you. So this basically completely bring heterogeneity into this. So a lot of kind of pre-processing, then processing, and keeping them your application in hand. A lot of processing has to be done, various and appropriate machine learning algorithm to be used to process that. Whenever the data models built using traditional data analytics or static machine learning algorithms constantly improve over time as more data is captured and assimilated. More accurate decisions can be taken. This means that the machine learning algorithm can make predictions, see what actually happens, compare against its predictions, then adjust to become more accurate. That is the inherent what we expect the machine to learn, and the learning should be the output what we are expecting from the system should be more accurate as we provide more amount of data into the system. When you are providing more data into the system, and deep learning is also gaining its popularity. A deep learning technology is based on artificial neural network, ANNs. These ANNs use learning algorithms and receive continuously growing amounts of data to increase the efficiency of training process. So you have more such layers here to process your data in deep learning. The larger data volumes are, the more efficient this process is. The training process is called deep because with the time passing, a neural network covers growing number of levels and layers. The deeper this network penetrates, the higher its performance. If you are using deep learning, you can expect better performance, but you have to provide a large set of data. So you will have this your multiple hidden layers, where traditionally if you see one neural network, one hidden layer is there, but you have multiple layers which helps your providing better performance from deep learning. So deep learning can enable Internet of Things devices to interpret unstructured multimedia data. So that is primarily people thought of more suitable kind of thing where different type of features and all can be extracted and intelligently react to other user and environment events, but has demanding performance and power requirements. So various kind of, that means you need more amount of data, more processing you have to do when you want to provide some accurate result. Deep learning is gaining much popularity due to its supremacy in terms of accuracy when training with large amount of data. So this is what more important for this point, for this deep learning. Deep learning is a promising approach for extracting accurate information from raw sensor data from IoT devices deployed in complex environments. Video sensing is an important IoT application which integrates image processing, computer vision in IoT applications. So in traditionally, there people use this deep learning in for various applications. Those applications also part of some of the video applications are also part of IoT networks. So it is still a challenge to recognize objects from low quality data recorded by IoT devices. So when you say that low quality, if you have IoT devices, you can't afford a very good kind of device which captures good quality video in IoT devices. So these are tiny devices, IoT devices are tiny devices. So still it is challenging to recognize objects from low quality video. So what we understood, we have seen various kind of applications, and these are your and how this machine learning and all, where to do machine learning, what is the necessity of machine learning, and how to provide such a solution for IoT applications. If you heard about cloud, you might have heard about fog computing. This is basically, fog is some kind of extension of the cloud, and this some of the resources are kept near to the application area or near to the end user, bringing intelligence down from the cloud close to the end user. Some kind of processing earlier you are using here, whether you are applying machine learning, any machine learning model or deep learning model, whatever maybe, but some of the processing you want to do it here, near to this. Okay, and some amount you can do it centrally. So bringing intelligence down from the cloud close to the end user. Base stations, routers, Wi-Fi gateways will be capable of running applications. Even if some processing you can do at the fog, which is not which is sufficient enough, do processing or apply machine learning for this region. So that no need of sending that one to cloud will do and it will send back to this one. So this basically it is some kind of extending some resources near to the end user or this layer. So what is the benefit? Customized requirements. This region, what is needed may not be needed in this region. Here it may be surveillance application. Here it may be vehicular network application. So that type of resource which are required for this layer, that can be kept here. The type of resources required for this application can be kept here. If they overlap, that's fine. Right. Then the faster communication will be faster, and after processing, locally this problem will be resolved. If these resources are not enough to cater service or to process this, then that processing can be done at the cloud. So it is an integration of cloud, fog, IoT layer. Right? So base stations, routers, Wi-Fi gateways will be capable of running applications. Sensors are able to perform basic data processing. In this case, close to devices lowers response time. So that is what response time will be lower. Customized services can be provided each layer, and processing will be done here and locally, and responses can be given. And for the real-time applications, some real-time applications, delay will be less and all. Right. So some authors also propose in a different way. They say that earlier you can apply deep learning at the cloud. So you can give input, you can your extract features, and this is your output. Now this processing you can also do at the some amount of processing you can do at the fog layer. Right? Yeah, I'm not showing your fog layer. It is directly IoT to the cloud. If there is no fog, so these are the IoT devices, and they through a IoT gateway they send it to cloud. Right? This is a typical IoT architecture. Right? But these IoT devices generate a different type of data. Now we introduce the fog or edge layer. So some people use your edge server or you are doing some fog computing. So similar purpose they are used. So so then this layer actually what it does, this edge devices will do some computation, edge server you can say here, and some server some processing we can do it here. So IoT device will send the data, and for edge servers will do, or this second layer will do some processing, then some processing will be done at the cloud layer. So first train the deep learning network. When you are deploying, you can train the deep learning network in the cloud server. After training phase, divide the learning networks into two parts. One part includes the lower layers near the near the input layer, input data. Another part include the higher layers near the output data. Deploy the part with lower layers into the edge servers and the part with higher layers into the cloud server. The collected data are input to the first layer in the edge server. So IoT data will be collected and processed at the edge server. The edge servers load the intermediate data. You will get intermediate data from the edge servers, from the lower layers, then transfer the data to the cloud server as the input data of the higher layers for further processing. How to divide each deep learning network? Usually the size of the intermediate data generated by the higher layers is smaller than the generated by the lower layers. So this is basically, you have to understand properly how to generate, understand the model, understand the input, understand the layers. Deploying more layers into edge servers can reduce more network traffic. So if you want to reduce more network traffic between your edge server and the cloud, then deploying more layers into the edge server can reduce more network traffic. However, the server capacity of edge servers is limited compared to the cloud server. So the server capacity of the edge server is limited. Therefore, I told how much processing you can do at the edge server based on the capability, because edge server processing power will be limited. So you can do that much processing. It is impossible to process infinite tasks at the edge server. Every layer in deep learning network will bring additional computational overhead to the server. Therefore, you have to decide how much processing to be done at the fog layer, how much processing you can do at the fog layer, how much processing can be done at the cloud, so that overall performance in the network you can improve, or you can you can improve, or you can find out, you can enhance the overall performance of the network. So we can only deploy part of the deep learning network into the edge server due to resource limitation. So that's all from my side. So if you have any query, you can please ask.
Thank you so much, sir. Now, if anyone have any queries, then feel free to drop your questions in the chat box. Is there any questions, viewers?
Good morning, sir. I have a question.
Yeah, please go ahead.
How can we design an optimal wake-up scheme which helps to avoid working more nodes than necessary?
Okay, can you please repeat your question?
Yes, sir. How can we design an optimal wake-up scheme which helps to avoid working more nodes than necessary?
Optimal wake up.
Means,
Are you
scheme.
speaking about sleep and your active
Yes.
nodes in the network?
Yes, sir.
Okay, right. So how to design means an optimal scheme for that you are telling, right? And if you have a number of nodes deployed in a region, right?
Yes, sir.
Suppose you have deployed some nodes here, right? So what you are saying that these are the sensor nodes. These sensor nodes will have a sleep period and active period, right?
Yes, sir.
So how much percentage time they will sleep and how much percent time they will be active? That is your question?
Yes.
Okay, right. Now, if you are dealing with your this type of sensors, and you are thinking that the coverage of the network is this much area is given, and these many sensors are there, and sensors, if you see, the device will sense some parameters. But what is the sensing region? Sensing region will be there. Some amount of some region will be. This is the suppose the sensing region. Now there is a communication region also, as I told you earlier. Every node will have some communication region. Now, when you say that nodes will sleep and active, why you want a nodes will be sleep? Because nodes wants to conserve energy. They want to reduce their energy consumption so that they can work for longer period. So you can improve the lifetime of the network or the individual node, IoT node. It doesn't matter, right? Now, if you say there one scheme is, suppose these are the 4 nodes. If all of them active at the same time, then they can communicate among each other. Again, they will go to sleep state. So that means, suppose I say 10% time they are active. So at a time all are active, they will communicate. Depends on how much data they want to share among each other. Based on that, you have to choose how much period is required when they are active. So 10% time, 15% time. Then next they will go to sleep state. Now, this type of methods, in specifically in sensor network domain, wireless sensor, we say that coordinated duty cycle. They have coordinated duty cycle. Duty cycle means how much percentage of time the node will be active. 10% time it is active. Definitely 90% time it is not active, right? Or it is in sleep state, right? It is called coordinated duty cycle. For that, they have to exchange the schedule. Which 10% they have to be active? Which 10% time? Is it 10% time is sufficient? That depends upon how much data they want to share. But they should know when they will be active all together. There should be coordination among each other. This schedule of activity or when they will be active and all, it should be shared among themselves through control message exchange. This is called coordinated duty cycle. Is your question is answered?
Sir, thank you.
And there is another type also, random duty cycle. So I'll not come to that. So there is another category of duty cycle is also there.
Sir, friendship-based routing algorithm is helpful for IOV or not?
Can you tell me the functionality what you want rather than naming it? Can you tell me what approach you will follow?
Sir, means I want to transfer one data to suppose a crash is there. So before crashing, the driver can get the message that a crash happened ahead.
Yes.
In that case, sir.
If there is a crash, no. What you want actually? If there is a crash, driver should get information.
Drivers should get information that I had a crash is happening. Then also they get the information. They get the information for the shortest route to reach the destination.
Yes. So what is your what you want? You want means you are concerned with what issue? Already I told you there are blockages on the roads, right? There are blockages on the road. This information should be sent from various sources, so that centrally it will be processed and appropriate information given to the driver. Now, are you looking for routing, rerouting that path information? You want that?
Yes, sir.
So you can this rerouting kind of information you are asking, right?
Yes, sir.
Okay, that the basically whatever the next shortest one will be found out, right? You can go through. I showed you one of our paper is there, right? So this using OSRM server and all we have done. So you can go through that paper.
Yes, sir. Thank you.
Thank you so much, sir.
Sir,
You have collected Results and conclusions were all we needed to hear. We sincerely appreciate your informative presentation and effort. We are very grateful to you, sir, that you took time off your busy schedule to address our small group. Thank you, sir.
Yeah, I'm thankful to you, your institution, and all the participants for hearing me. Thank you all. Thank you.
Yes, sir.
Now, ladies and gentlemen, the attendance link is provided in the chat box. All of you are requested to check whether you have filled that or not. The participants who have already filled are requested to leave this meeting and join the next link provided for the next technical session, which will be taken forward by Mr. Subrat Kumar Acharya. Please join quickly so that you won't miss anything. Thank you so much, all.